Today we will start seeing the topic that it's called difference of squares. Difference of squares, as the name says, we must have two terms, one positive and one negative, to be a difference. And the terms must have a specific or exact square root, and their exponents should be per exponents to become or to have a specifically a square root. So in this case, the difference of squares will be factorized in product of the sum and difference of a binomial. If we remember special products, when we get a difference of squares, in this case a squared minus b squared, the a squared, that is the positive one, in the product of the sum and difference will be positive on both parentheses. The one that it's negative, in this case minus b squared, is going to be positive on the first parenthesis, negative on the second parenthesis, and that's why when we multiply these two parentheses we get a squared minus b squared. So remember, factoring, it's the opposite of multiplication. That's why from the answer that it's called difference of squares, we will get the special product that it's called product of sum and difference of a binomial. Let's start with today's examples. On the first example, we have something like this: 25x squared minus 36y to the 8. We can check out if it's a sum and difference of a binomial if both terms have a specific exact square root. In this case, we have it because the first term, the square root of the first term is 5x. The square root of the second one is 6y to the fourth. So if both terms have a square root and it's one positive, one negative, then I can put it as a product of sum and difference of a binomial. Remember, the one that it's positive will be positive on both parentheses. The one that it's negative, it's going to be positive on the first parenthesis, negative on the second parenthesis, and in this case we need to check out if it's correctly ordered. It's correctly ordered because we have first x then y, and on the second parenthesis also first x then y. So this is the actual correct answer for this specific first exercise. So let's see another exercise. So in this second exercise we have something like this, also two terms, one positive, one negative. We need to check out if they have exact square root. In this case it's going to be 13 x squared y to the third and 12 a to the 4 b to the 6. So remember, in this case, so I will do two parentheses. The one that it's positive will be positive on both parentheses. The one that it's negative, it's going to be positive on one parenthesis and negative on the other one. Remember, we need to check out if it's correctly ordered. So in this case, the first parenthesis is not correctly ordered because it should be first 12a to the 4th, then x. So it's going to be 12a to the 4 b to the 6 plus 13 x squared y cubed. The second parenthesis is correctly ordered because it's a binomial with a positive and a negative one, so the positive one should go first. So it's going to be 13x squared y cubed minus 12a to the 4 b to the 6. We cannot take out anything of the parentheses because 12 and 13 doesn't have something that it's common. The letters are different, so this is going to be the final answer of this specific exercise of a difference of squares. So let's see another example. So let's check out the third example. In the third example, we can do it in two ways. So I will do it in two ways. The first one is the one that we have seen. The first term has a specific square root that it's 9x squared y, and the second term has also a square root that it's 10x to the third y to the 5. So in this case, they have both of them a square root, so I will put it like 9x squared y plus 10x cubed y to the 5. That multiplies 9x squared y. Remember, the one that it's positive, it stays positive. The one that it's negative, it's going to be positive on the first one, negative on the second one. Then, of course, I need to check out if we can take out something of the parentheses. On the first parenthesis, we have as a common x squared y, so I can take it out of the parentheses. So it's going to be 9 plus 10x y to the 4. On the second parenthesis, it's going to be something very similar. We can take out x squared y, and it's going to be multiplied by 9 minus 10x y to the 4. So finally, we can join these two. It's going to be multiplied x squared and x squared. It's x to the 4, y multiplied by y squared. The first parenthesis is not correctly ordered, so I need to order it, and it's going to be 10x y to the 4 plus 9. This parenthesis is correctly ordered because it's a positive first, there's negative after it, so it's 9 minus 10x y to the 4. And in this case, this is going to be the final answer, where we can take out something of the parentheses. It's correctly ordered. So that was one form of doing it. The other form will be something like this. We have 81 x to the 4 y to the second minus 100 x to the 6 y to the 10. So we can take out what is common on both terms, that is x to the 4 y squared multiplied by 81 minus 100 x squared y to the 8. Then, of course, this that it's inside the parentheses, it's also a difference of squares. So the root of the first one is 9. The root of the second one is 10x y to the 4. So I will put it like x to the 4 y squared. And then remember, it's the one that it's positive. It's positive on the two parentheses. The one that it's negative, it's going to be positive on the first one, negative on the second one. So now I only need to order it, and it's going to be x to the 4 y squared. That multiplies 10x y to the 4 plus 9. That multiplies 9 minus 10x y to the 4. And we can check out that this specific answer, it's the same as this specific answer. So you can do it both ways. You can first do the difference of squares and at the end take out what is common inside the parentheses, or we can take out first what is common on the binomial and then do the difference of squares. So it's up to you. You can do it on the first form that I explained it. You can do it on the second one, but you will get the same answer on both a specific exercise. Let's see another example. So let's see, in this exercise we have fractions, but the fractions have a specific square root, so we can do it because the first term has a specific square root that it's 4/5 of x to the 4. The second term has also a specific root that it's going to be 6/7 of y to the 6. So remember the rule, it's the one that it's positive, it's going to be positive on both parentheses. The one that it's negative, it's going to be positive on the first one, negative on the second one. We need to check out if it's correctly ordered. In this case, it's correctly ordered. We cannot take out anything. So in this case, this is going to be the final answer of the exercise with fractions. So it's the same. If the fraction has a specific exact square root, we can do an exercise of difference of squares. Let's see one last examples of difference of squares. So in this example, we have something like this with letters as exponents, but remember, we can do it the same because the first factor has a specific square root that it's going to be 11x to the a. The second factor has also a specific square root that it's going to be 8x to the 2b. So in this case, the rule, remember, it's the one that it's positive. It's going to be positive on both parentheses. The one that it's negative, it's going to be positive on the first one, negative on the second one. It's correctly ordered because exponent a should be, or it's going to be first than exponent 2b because a comes before 2b in the case of the alphabet. So this is going to be the final answer of this specific exercise. So I will do another one that I think it's kind of tricky. So I will do one last exercise for difference of squares. So as I was telling you, this last exercise can be a little tricky, so I will do it with you. In this specific exercise, we have also two forms of doing it because we can see they have a specific square root, so I can start doing the difference of squares because the first one is 6x to the 2a. The square of the second one, it's going to be 4x to the 4. I'm sorry, here it was a to be the one that it's tricky. So it's going to be to the 4a. So in this case, it's going to be on the first parenthesis, 6x to the 2a plus 4x to the 4a. And on the second one, it's going to be 6x to the 2a minus 4x to the 2a. Remember, in this case, we need to check out if we can take out something of the parentheses. Of course, I can do it because I can take out 2x to the 2a on the first one, and it's going to be multiplied by 3x. I'm sorry, not 3x, only 3. Because if it was by 3x, it's going to be 2a plus 1. So no, it's going to be only multiplied by 3 because 3 multiplied by 2x to the 2a, it's going to be 6x to the 2a. Then it's going to be plus 2x to the 2a to become 4a. On the second parenthesis, I can take out also 2x to the 2a, and it's going to be multiplied by 3 minus 2x to the 2a. So I can join these two, and it's going to be 4x to the 4a. The first parenthesis is not correctly ordered, so I need to order it, and it's going to be 2x to the 2a plus 3. The second one is correctly ordered because first the positive, then the negative one. So this is going to be the final answer of this one. So remember, we can do it also if I can take out what is common on the beginning of the exercise. So let's see, 36x to the 4a minus 16x to the 8a. If I can take out what is common on the first step, I can take out a number 4. I can take out x to the 4a, and it's going to be multiplied by 9 minus x to the 4a. What it's inside the parentheses, it's also a binomial or a difference of squares. So in this case, because the first one has a square root, exact square root, that it's 3, the second one has also an exact square root that it's going to be 2x to the 2a. So now I can put it like 4x to the 4a. That multiplies 3 plus 2x to the 2a multiplied by 3 minus 2x to the 2a. Remember, we need to put it in the correct order because this specific binomial is not correctly ordered. So our answer is going to be 4x to the 4a. That multiplies 2x to the 2a plus 3. That multiplies 3 minus 2x to the 2a. So we can check out. We have this answer that it's the same than this answer. So remember, when we can take out something at the beginning, it's up to you. You can do the exercise. First applying the difference of a square root rule and then getting out of the parentheses what it's common, or we can take out what it's common at the beginning and do the difference of squares of what it's inside these parentheses. So that will be all for this topic that it's called difference of squares.